Hi, welcome to the Introduction to Data Science course. This is a short video to show you some of the things that we might be doing in this course and the things that you'll learn how to do. We're going to be working on a very simple data set here. It's sort of a classic data set in the field of data science and statistics. It's the Fisher-Iris data set that you may already be familiar with, and if you aren't, well, welcome to data science. So we're actually working in a Jupyter notebook here, and we're going to be executing some Python code interactively to have a look at the data. So I'm loading in some libraries first here. And in this cell, I'm actually loading in the data set. The data set is available through scikit-learn. I actually imported it right here, the load_iris function, and then I'm assigning the result of load_iris to this variable right here. This is actually going to create some clean names that we're going to see in our data frame in just a moment, which is right now. And let's have a look at this data frame before we go on. We'll just show the head, which is in this case the first few rows. So you can see we have this is the first 5 rows of the data set, and it's describing some flowers, some iris flowers, and some measurements taken for these flowers. So the sepal and the petal are different aspects of the flower, and we're recording the length and the width of each of these here. And these are the variables or the features that we're going to be looking at. So one thing we might do as data scientists is actually look at the distribution of the features over the entire data set. And what I'm doing here is restricting the distribution of these features to values between -3 and 3. And what's interesting about this is that we can't see the sepal length at all. We can barely see the sepal width, but the petal length and the petal width are actually fairly visible. What this value represents is the probability that a certain value will be recorded. So, if we're looking at this value right here, that's the probability that a value of 1.5 would be recorded. So what we're going to need to do if we're going to compare the different features is we need them to be on the same scale. So I'm going to use a standard scaler to get them on the same scale. And let's go ahead and have a look at the head of the scaled data. And you can see we've actually moved the values around. It's a little bit hard to see exactly what happened just looking at the data itself. But again, we can generate these plots. So the first row represents the original data, and the second row represents the scaled data. And what you can see now is that all 4 features are on the same scale. And what we've done essentially is make it so that the mean or average value of the data is 0, and that each of the features has a standard deviation of 1. So you can see they're all they have different shapes, but the shapes are centered and about the same size around a value of 0. And so this is a fairly common thing that we do in data science. So we're going to generate a few more plots to have a look, get a better sense of this data. And what we've got here is we've taken the 4 features and we've generated a set of combinations of these features. So for 4 features, there's 6 possible combinations. So here we're comparing sepal length, sepal width, sepal length to petal length, sepal length to petal width, so on and so forth. And then you'll notice that there are different colors here as well. And what these colors represent are different kinds of flowers. So what's interesting here is we can actually see there's some pretty good groupings. So for example, here, the purple designation is actually fairly well separate from the other flowers. And the same thing happens here, and here, and here. And this is actually, it means that we're going to be able to do some nice clustering with these flowers when we eventually get to there. We're going to be able to do some really nice classification when we get there. It's a data set that's fairly well behaved. There's a clear difference in terms of the variables recorded for the different types of flowers. But of course, that'll come later. Today is just sort of an introduction. We're just looking at different kinds of plots and what we might see for this data. So the last thing that we're going to do here is one of my favorite things to do, is to generate a principal component analysis. And it's fairly simple using scikit-learn in Python, and it takes just 3 lines of code here. So once again, now I have another set of data. We can look at the head, and again, these values don't mean much to us. So let's go ahead and visualize what we've done here. So what these represent are the principal components of the data set. And this is a very challenging topic. This is going to take a long time for even the most seasoned mathematician to really make sense of what we're looking at here. But the most important thing is that 73% of the data is explained by just one column here, one principal component, and another 23 is explained by the second principal component, which means we can largely ignore these other 2 features. Now these 4 features are not sepal length, sepal width, petal length, or petal width. These are actually new components that are combinations of the original features. And so what we've done is we've recombined to create new features. And in doing so, we are able to get rid of these 2 features, these PC3 and PC4 almost entirely, which means that we can plot the data using just 2 features. And here we go. We've got a plot here of the data using just principal component 1 and principal component 2. And again, we can really see this clear separation between the different kinds of flowers. So this is an introduction to the class, and this is a very good presentation of the kinds of things that we'll be doing in the class. We'll be doing these different sorts of transformations on the data and then running them through different models in order to get a better sense of what is there. And then hopefully in the end, we're going to be able to actually do this to do inference and prediction on the data. So welcome to the class, and we'll be doing this a whole lot more.